Hello students, I am Shakti Kumar, lecturer chemistry, and this is tutorial on molecular formula and empirical formula. This is topic from class 11th chemistry, unit 1, that is some basic concepts of chemistry. Let's start the topic. Let's talk about molecular formula and empirical formula. First, molecular formula. Molecular formula represents actual number of individual atoms in a molecule, like C6H6. In this formula of benzene, there are 6 atoms of carbon and 6 atoms of hydrogen. And if we write its simple formula, that is empirical formula, that represents only simple whole number ratio of individual atoms in a molecule. So empirical formula for benzene can be written as CH, which represents simple whole number ratio of carbon and hydrogen. Here the ratio is 6:6. Here ratio is 1:1. Now let's proceed. So molecular formula for glucose is C6H12O6, and the ratio of the individual atoms is 6:12:6. And when we write the whole number ratio by dividing each individual by 6, we get 1:2:1. This is simple whole number ratio, and this was its actual number of atoms in the molecule. So empirical formula for this molecular formula will become CH2, because carbon, hydrogen and oxygen are in ratio 1:2:1. So carbon is 1, hydrogen is 2 and oxygen is 1. Now let's see the definitions. So molecular formula, it represents actual number of each individual atom in the molecule. For example, C6H6, which I have shown you earlier, is the molecular formula of benzene, and for empirical formula, it represents simplest or smallest whole number ratio of the constituent atoms within the molecule. And the empirical formula for this formula of benzene is CH. So what's the relation between molecular formula and the empirical formula? So molecular formula equals to n times of empirical formula. Like earlier we have seen that if n is 6 and empirical formula is CH, then it will become CH6 into CH. So it becomes C6H6 like this. So molecular formula is finally n into empirical formula. Now, molecular mass calculation. What is molecular mass? Let's see first. Molecular formula we have calculated, empirical formula we have calculated. In order to calculate the molecular mass, we have to calculate the mass of individual atoms. For example, what's the atomic mass of carbon, what's the hydrogen, and what's the atomic mass of oxygen. So in case of this empirical formula, what will be the molecular mass? Molecular mass of carbon. Carbon is one part, so 1 into 12 plus hydrogen 2 into 1 plus oxygen 1 equal to 16. So it's 12 plus 2 plus 16, and it will become 30 AMU for this formula. If we take the formula like this, so for this 1 into 12 plus 1 into 1, it will come 12 plus 1, 13. So finally the molecular formula of CH2 is 30 AMU, which we have calculated over here. Now, percentage composition. What is percentage composition? You see, the mass percentage of each constituent element present in any compound. Mass percentage. What is the mass percentage of? Mass percentage of each element in any compound. So we can write mass percentage of an element like number of parts by mass of element. Number of parts by mass of an element divided by molar mass of the compound. For example, you see here we'll see the mass percentage of this empirical formula of each individual atom. For example, carbon is one part and its atomic mass is 12, and mass percentage we will calculate over here. So for carbon 1, atomic mass is 12 and mass percentage is 12 upon 30. That is number of parts by mass of element. One part upon molar mass of the compound, which is 30, and mass percentage will come 40 for this. Carbon is 40%. Similarly, for hydrogen, which is two parts in this compound. There are two parts of hydrogen in this compound, and 2 into 1 is 2, and when we divide it by molar mass of the compound, which is 30, it will come 6.66, and hydrogen is 6.66. Now we'll talk about the oxygen. Oxygen is one part, and atomic mass of oxygen is 16. And after calculation, atomic mass divided by molar mass will get this percentage. So this is the percentage of individual atoms, known as percentage composition of each atom, and when we add up these, it will come 100. That is the percentage. Let's solve a simple problem. Here in this problem, a compound contains 40% of carbon. Carbon is 40%, and then hydrogen which is 6.66%, and the oxygen is 53.33%, and the molar mass for the compound is 180 grams, and we have to find empirical formula and molecular formula. So in order to solve this problem, we have to follow some steps. So first of all, we will write the elements involved in the problem, that is carbon, hydrogen and oxygen. After that, we will write the symbols of these elements, which is carbon, hydrogen and oxygen, and after that we will write the percentage of the elements, which is given here. Carbon is 40%, hydrogen is 6.66%, and nitrogen is 53.33%. So after writing this, we'll write atomic mass. Carbon is 12, hydrogen 1, oxygen is 16, and thereafter we'll calculate moles of the elements, that we calculate by dividing percentage by atomic mass. And 53 upon 16, and we'll get the number of moles. But these figures are fractions, so in order to remove these fractions, we will divide each one with the smallest one. So after dividing, we got the simplest whole numbers for each atom, and this is the simplest whole number. With the help of this, we will write the empirical formula, which will come C1H2O1, and from this empirical formula we will calculate molecular formula. Molecular formula equal to N into empirical formula. So first of all, we have to calculate molecular mass for this empirical formula. So after writing empirical formula, we will get molar mass for the empirical formula, and carbon is 1 part, hydrogen 2 part, oxygen is 1 part, and after writing their atomic masses, we got 30 AMU, which is empirical formula mass of this compound. And from here we will calculate the N by dividing the molar mass of the compound, which is given, and after that we got empirical formula equal to 6 into empirical formula, and this is our final molecular formula, because N is 6 and we have to multiply this formula by 6. So finally we got this answer. Okay. Now the home assignment, the problem 1 is a compound contains 4.07% of hydrogen, 24.27% of carbon and 71.65% of chlorine. Its molar mass is given. What are its empirical formula and molecular formula? By following the given table, you can solve the problem easily. Here is second assignment, which can also be solved following the given tables. We have to put over here first elements, then symbols, then percentage of the elements, then atomic masses, and with that you will calculate number of elements of individual moles of elements, and then write simple whole number ratios, then simplest whole number ratios, and after that you can calculate the empirical formula mass, and then divide that empirical formula mass with the molecular formula mass, and you will get the things done.